Hello students, we are going to start a new chapter today, thermodynamics. Okay, I'm saying thermodynamics. Okay, the word thermo is coming over here. It means what? Heat, isn't it? So here actually basically in chemistry what do we study about? We study about the chemical reactions. So why these chemical reactions are taking place? Okay, why they occur, why these chemical reactions are going on. Okay, actually what happens whenever anything is unstable. Okay, when I'm saying unstable means what? It is having higher energy. Naturally what happens? They will combine to form the product of what? Lower energy, so that it can be stable. So all this study of energy transformations we are going to study in thermodynamics. Okay, here we are seeing what? Anything or at what? Microscopic level. Okay, macro means big. Okay, till now what we have studied, atomic structure, chemical bonding and all, they were dealing with what? Microscopic level. Why? We were studying about atoms, we were studying about molecules, but here we will be not studying about atoms, molecules at that level. We will be studying with the bulk. Okay, and when we are talking about the bulk, it becomes what? A macroscopic system, like temperature, pressure, volume. Okay, these all things are what? Macroscopic in nature. So in this, the laws deals with the energy changes of the macroscopic systems. Okay, the big, at a big level, at a bulk level. Okay, now here the laws apply only to the system which is in what? In equilibrium, or it moves from one equilibrium state to another equilibrium state. What does this mean? Actually what happens? It tells about the system or the reaction which is getting what, or attaining equilibrium position, or it moves from that equilibrium position to another equilibrium position. Okay, so these all the laws will be moving around this only. Okay, so what is the importance of this thermodynamics actually? Actually it predicts whether any given chemical reaction can occur under a given set of conditions. Naturally here it can say that how much energy should be required, okay, how much heat should be supplied. All this can be said according to this thermodynamics. It can say that yes, if this much energy is not supplied, or if this much energy is not there, the reaction will not take place. Okay, now here it also predicts the reaction before the equilibrium is attained. Okay, it also says about the reaction, when will these products will be formed, when will the equilibrium will be attained. Sometimes what happens, the reaction attains also equilibrium, okay, and then again it reverses back. Why does this happen? Actually this happens because what happens in the product, now the energy becomes more, and if the energy is becoming more, it is again becoming unstable. As the result, the reaction will reverse to the what? The reaction side, and we see that yes, the reversible reactions are occurring, because this is because when once attaining the equilibrium, more energy, again the reaction reverses back. Okay, so basically in thermodynamics we will be studying these only, okay, at a large level, our surroundings, okay, and how the transfer of this heat or energy is going on. Now let us study about the thermodynamic terms. Okay, what are the terms which are used in the thermodynamics to study it? Okay, so first of all, system. Okay, when I am saying system, system means what? The chemical reactions. Okay, because we are studying chemistry, so here we will be focusing on the chemical reactions. So system is what? The chemical reactions, okay, the reactants, okay. Now surroundings, the reaction in which surrounding it is being taking place. So this system plus surrounding is known as universe. Okay, now whenever there is a chemical reaction, okay, we say that it is a system, reaction is going on, okay, and it is surrounded by what? Surrounding. Okay, but what separates this reaction between the surrounding is the known as what? Boundary. Okay, now this system, when we are saying, it is of three types. Okay, open system, closed system and isolated system. Okay, in what condition the reaction is going on? Okay, here we are going to see that actually. Okay, see, you can see the system is here in this. when we are saying that it is an open system, it means in that transformation of matter as well as energy is taking place. Okay. But when we are saying closed system, okay, then only energy transformation is taking place, matter not. I can give you an example like beta. Take a vessel, okay, keep water in it and don't keep the lid on that, okay, heat it, okay. When you are heating it, what is happening in that? Energy transformation is also taking place. As the lid is not present, what is happening? Matter transformation is also taking place because water is being evaporated, isn't it? Some water escapes out in the form of water vapors, isn't it? So that is an open system. When we are saying about closed system, we can take the example, okay, in which this only the water which you have taken in the vessel, okay, you are heating it, you put on the lid on that, okay, and as soon as you put on the lid on that, can you see the water vapors going up? No. So matter change is not taking place, no transfer of matter, but yes, energy transfer is still going on, isn't it? But when we talk about an isolated system, the third system, okay, keep that water in a flask, okay, what happens? You will see that it is hot for a longer time, it is hot, isn't it? And if it is airtight, it is difficult to get cool also, or to lose the temperature. In that, what happens actually in the thermoflask? Here no energy transfer, no matter, nothing is being transformed, okay, no participation of transformation of what energy and matter takes place in isolated system, okay. So three types of system: open system, closed system and isolated system. Now, coming to the next term, state of the system. In which state the system is, in which condition the system is, or in which position the system is, okay. It is seen by what, or it is determined by what? The state function or the state variables, okay. You are familiar with these terms, pressure, volume and temperature, isn't it? So these all are what? State functions or state variables, okay. They have the capacity to change what? The state of the system, okay. So these terms, actually pressure, volume, temperature, you all right now know because you have studied states of matter, okay. Here we are going to study about internal energy. Internal energy is also a what? State function. Simply if I say you all internal energy, what is internal? The energy which you consume, isn't it? Likewise, what is this internal energy of state function? Actually here we are seeing what? Sum of all the energy of the system, okay. This system here I am saying what? The reactions, the chemicals, okay. Here what is happening? It is consisting of potential energy, it is consisting of kinetic energy. Naturally they are colliding, energy is becoming different. Summing up all the energy tells about the internal energy of the system, and that is a state function, okay. Now, so how can this internal energy change? This internal energy can change. How? If heat is given out, or heat is supplied to the system, okay. If the heat is also supplied to the system, or if the heat is given out by the system, internal energy will change, okay. Second, if work is done on the system, okay, or if the work is done by the system. If the system is doing some work or some work is being done on the system, both will change the internal energy of the system, okay. Now, next, matter. If matter enters the system or matter leaves the system, this also can change the internal energy of the system. Like for example, you can say like if we are adding catalyst to a reaction, what happens? We are seeing that yes, the reaction is being accelerated, isn't it? So this matter also determines the internal energy of the system. So beta, one question must be arising in your brain, that always I am talking about the system, but we are not talking about the surrounding. Even though surrounding is also responsible for the changes in the reaction, Okay, actually we can't do anything with the surrounding what it is, it will be that. Okay, we can only do changes in the system. Okay, and that are our chemicals and the chemical reactions. So right now we have studied about internal energy, okay, and how that internal energy can change. It can change due to work, due to heat, isn't it? One by one we will be studying. Due to work, when we are saying, for explaining this, we have taken a system, okay, in the surrounding. But the system we are seeing in this what? There is no exchange of matter and energy. And as there is no exchange of matter and energy, Q becomes 0. This small q represents what? Heat. Okay. So here what happens? This heat becomes 0. And this type of system in which no exchange of matter and energy is taking place, okay, this type we can say that is isolated system, and the process which we are saying is what? The adiabatic process. Okay, because here no transfer of heat between the system and the surrounding. Okay, so now if there is no change in heat, so what happens? Change in internal energy if somehow, okay, if we increase the volume, okay, or decrease the volume, okay, then there can be a change in internal energy. Okay, here Q is 0, but yes, if somehow there is a decrease or increase in volume, so naturally here, as there is no change in the energy and all, Q is 0, we are saying it is the adiabatic process. Okay, but yes, if some volume is increased or decreased, what happens? How we will be calculating it? We will be calculating it internal energy final minus internal energy initial. Okay, U2 minus U1, and that is said to be work done adiabatic. Okay, now if work is done on the system, we are saying it is positive, and if work is done by the system, if the work is done by the system, we are saying that it is negative. Okay, now heat. Heat, how does it? We will be explaining it again with the help of system and surrounding. Okay, but here we are seeing in the system energy transfer, energy exchange is being taking place, but no exchange of matter. Okay, so here naturally this heat will be there, isn't it? So here we are seeing what? Volume is constant. Okay, no work is done, as here we are seeing that volume is constant. So what we will be saying? That yes, no work is being done. Okay, so here internal energy, change in internal energy will be equal to what? Heat, isn't it? So here we will be saying Q, heat, is positive when the work is done from the surrounding to the system. Okay, and work, this heat is said to be negative when system is working. Okay, here work is done by the system in the surrounding. Okay, here you can see, yes, it is gain of heat, it is loss of heat. Okay, work is done and work is done by the system and the work is done on the system. So we have studied, yes, what? That internal energy that depends upon what? Heat and work. Okay, so change in internal energy, if we will sum up this heat and work, we'll get, isn't it? So change in internal energy is equal to heat plus what would the work. Okay, so this only says about what? The first law of thermodynamics. Okay, now in an isolated system, what do we see? That Q is equal to 0 and W is equal to 0, isn't it? So now putting this equation in this change in internal energy, we are writing what? Q is equal to 0 and work done is equal to 0. Sum it up, you will get what? 0. So now if we are getting the value 0, it means, is there any energy transfer or any change in the internal energy? No. So if there is no change in the internal energy, what it is? Energy is constant. So now here we can say that yes, energy can neither be created nor be destroyed. Okay. But if we are taking any other in which we are saying that yes, there is a change in internal energy. Okay. Then in that, will this first law of thermodynamics be applied, or this will be said that yes, energy can neither be created nor be destroyed? Here there is a change. But why there is a change? Okay, this only we have to understand. It is not that in the system anything is happening by its own. Okay, actually how much amount of heat is applied by the surrounding on the system, or the system is giving out to the surrounding, or work done by the system or work done on the system. Okay, these are only changing, and that is what this Q and W only. Okay, and so here also nothing is done by itself. It is only that which we are supplying or applying to it. Okay, and so here also what will happen? Energy is neither created nor destroyed. Okay, it is not happening by its own. We are supplying to it, or it is doing some work, and then only it is happening. So we can say over here energy is neither created nor destroyed, and here also first law of thermodynamics is applicable. Hope you might have understood it. Good day. Take care.